Okay, in this section, we're going to be looking at some other ways or some other rules for finding derivatives that you'll have to use. So we're looking at what's called the product rule and the quotient rule, and then again in a minute we'll look at what's called higher order derivatives. So we're looking at product rule first. So what you have here for this rule would say if you're asked to take the derivative of two functions, so you have one function they're referring to as f of x, you have another function they're referring to as g of x, and of course you're asked to take the product. You're multiplying those together. So this is the rule that you'll need to remember. You actually just start with the first function, f of x. You would just write it down like it is. And then you multiply that times the derivative of the second function. So see, here's that derivative notation. And then you're going to add, and then you take the second function as it is and multiply it times the derivative of the first function. Now, since this is addition, if you get these two sides flip-flopped, it's fine because it's addition. It would be the same thing. Okay, now, as this next sentence states, it says this can be extended to cover products involving more than two factors. So like if we had a f of x times a g of x times an h of x, we could actually extend this concept and still have product rules. So like it says, it'll work for more than just two factors. Okay, so here's the first one we're going to look at. So this is going to represent the first function that's referred to as the f of x in the rule that I had written down, and this will be the second function that's referred to as the g of x. But see, these two things are being multiplied together. That's why we can use product rule. So it's not just simply take the derivative of this, then take the derivative of this and multiply together. That's not the way your product rule works. All right, so start out with, like y prime. I'm going to use dy dx or y prime, it doesn't matter. All right, so as your rule stated, you want to start out by just copying down your first function as it is. So that would be the 3x squared minus 2x. Now you're going to multiply times that the derivative of the second function. Okay, so I'll just put it in parentheses to indicate the multiplication. So now, taking the derivative of this, of course, we learned in the previous section that you can take the derivative of these terms individually. The derivative of 4x would just be 4, and of course, the derivative of a constant is just 0, so there would be no need to put minus 0. So this is first function times the derivative of the second function, plus. Now reverse what you did. Now you take the second function, and you multiply it times the derivative of the first function. So again, you'll take the derivative of these terms individually. So the derivative of 3x squared would be 6x. That's just using your power rule. Remember, 2 times the multiple, and then you decrease your power by 1. Minus, and then you take the derivative of 2x, which would be 2. Okay, so you're done with your product rule. What we need to work on now is just simplifying. So here you would distribute your 4. You actually wouldn't have to put that in parentheses if you didn't want to. Now we need to multiply these two together, which would be FOIL method. Okay. Now, with this being addition, you don't really have to worry about your signs changing or anything, but if that were to be subtraction, you would have to remember to distribute your minus sign. But with product rule, it is always addition, so that won't be an issue. So let's just start combining like terms. So I'd have 12x squared plus the 24x squared. And then I have negative, we'll combine your x's to the first power, so you'd have a negative 8 minus the 30. So that's going to end up giving you negative 46. And this would be the only constant of plus 10. So this would be your derivative of this. Now, you actually could get your derivative of this in a different way, and it's something that we had talked about in the previous section before you knew product rule. If you wanted to, You actually could just FOIL this out, do, this times both terms, do this times both terms, and then combine like terms if you have any. Then you could take the derivative of that, which would end up actually taking the derivative of 3 terms, and you would end up with exactly the same answer. So sometimes there's more than one correct way that you can work these, but we're needing to learn product rule right now, so that's what I want you to concentrate doing on all of these problems is the product rule. Okay, next one. Okay, first thing that you would need to do here, well, before I say that, the square root of s would be your first function, so like this would be the f of x. This would be your second function, so this would be the g of x, okay? So that's, first of all, knowing what's your first function, what's your second function. Now, you're going to need to rewrite this as s to the 1/2 power, and we had to do that in the previous section with other radicals that we had. Now, you actually could do what I had told you that you could do on that first problem. If you wanted, you could take this and distribute and then apply your derivative rule at that point. But we're going to stick to product rule so that we've got the practice with that. Okay, so I need my first function times the derivative of the second function. Of course, the derivative of 4 is going to give me 0, so I would just use my power rule here, which would give me negative 2s, and of course that would just go to the first power, plus second function times the derivative of the first function. Okay, so using your power rule here, we would have 1/2 times s to 1 less power. So if you did the 1/2 minus 1, that would give you negative 1/2. Okay, let's multiply these two together. Now, when you're multiplying the s's, remember you're going to add your powers. This s is understood to be the first power, so 1/2 plus 1 would give me s to the 3/2. Okay, and if you wanted here, you could use your distributive property. So 1/2 s to the negative 1 times 4. So 1/2 times 4 would give me 2, and then s to the negative 1/2. And now do the 1/2 s to the negative 1/2 times the s squared. So that would be minus 1/2 s. Okay, now you're multiplying, so you're going to add your powers. So 2 plus a negative 1/2 is actually going to give you 3/2. Okay, these two would be considered like terms because you've got exactly the same exponent, so you would be able to combine these together. So you'd have negative 2 minus 1/2, so that would end up giving us negative 5/2 s to the 3/2 plus 2s to the negative 1/2. And one last thing, and I actually should have just gone ahead and done this in the same step. You would want to rewrite this term so that you have a positive exponent. And like I said, you could have done that in this same step right here. So you would need to carry the s to the denominator, which would cause your power to become a positive 1/2. Now, back of the book, answer, they're liable to get a common denominator here, but I would be fine with you leaving it at this step. Okay, next example. Now, I know I'm jumping to number 4 here. I had a number 3 that I've actually left out, so if you want to just call this number 3, that's fine. All right, so first function, second function. So the 5x squared would be your first function, and the cosine x would be your second function. Okay, so I'll just do y prime. So I need first function times the derivative of the second. So the derivative of cosine, remember, is negative sine, plus second function times the derivative of the first. So using your power rule on your first function, you would have 10x. Okay, so this would be negative 5x squared sine x plus 10x cosine x. And a lot of these problems, you'll see if they have a common factor, they will pull the common factor out front. So like you could do a 5 or a -5. That really wouldn't matter. I'm going to pull out a -5. But you also could pull out an x, because right here, you've got two x's here and an x here. So if I were to do that, I would be left with x sine x, well, and that would actually change to a minus, since I'm taking out a negative, and I would be left with 2 cosine x. So this would be probably the way that you would end up seeing your answer. Okay, looking at one more product rule here. Okay, so they've switched your variable here to be theta, which is fine. Now, this is actually, the whole problem is not product rule. Your product rule is only going to occur right here. Because this term, I mean, that's not a product there, that's just cosine theta. But here you have 3 theta times sine theta. So this is going to be your first function, and this is going to be your second function. Okay, so starting your derivative. So using my power rule here, well, let me say this. You know, we've learned in the previous section when you have a sum or a difference, you are allowed to take the derivative of those terms individually. So to be able to take the derivative of this first term, you would have to use product rule. Okay, so first function times the derivative of the second function, so the derivative of sine is cosine, plus second function times the derivative of the first function, so the derivative of 3 theta would just be 3. Now you're done with the product rule, which is this. So now we have our addition, and now we take the derivative of cosine, which is negative sine. Okay, so we have 3 theta times cosine theta plus 3 sine theta, and you could just rewrite this then as minus sine theta because it's adding a negative. And that's all you can do here. You don't have a common factor to all 3 of those terms that you can take out like you saw just a few minutes ago. So sometimes product rule doesn't apply to the whole function, like in this case product rule just applied to just that one part.